So find all of the asymptotes for this function. I'll start with the vertical asymptotes. This is going to be places where the function is undefined. That's caused by division by 0. So if the denominator, 8x squared plus 8x, is equal to 0, the function can have vertical asymptotes there. And then I'm going to factor this one. So factor out an 8x, it leaves x plus 1 equal to 0. Set each factor equal to 0. And from this one we get 8x equals 0. And x plus 1 equals 0. So the two solutions are x equals negative 1. And then we can take a look at the graph and see if that looks right. So here's the original function. And then take a look at the graph. And at x equals 0, sure enough, there's an asymptote. On this side, the function is going down, down, down to negative infinity. On the right-hand side, the function is going up to positive infinity. And if we trace and plug in a 0, the function itself is undefined. So this is correct. But something else happened at negative 1. So if I substitute a negative 1 for x, I find out, sure enough, the function is undefined, which means that I did this algebra correct. But there is not an asymptote at negative 1. The function doesn't split off and go up and down to negative infinity or something like that at negative 1. So this is actually called a removable discontinuity. So that means if we go back to the original problem, it can be factored, and let's see, the top can be factored as x plus 7 and x plus 1. The denominator, as I did over here, can be factored as 8x times x plus 1. So while the function is undefined at negative 1, we can actually remove that asymptote, and only x equals 0 is a vertical asymptote. So it's always good to check your work. Next, we need to check for a horizontal asymptote. And for that, you can basically say, well, this function, for the numerator, what controls it is the x squared term. This is the most powerful thing. It's much more powerful than adding a 7 or even adding 8 times a number. Squaring is much more powerful. The same thing happens down here. So we can say that the h function, or for graphing in the xy system, the y value, can be approximated by just the x squared over 8x squared. And then reduce, and we get that it's 1/8. So y equals 1/8 is going to be the horizontal asymptote. So that means that if we graph in the xy system, there is a vertical asymptote. So the function is going to get closer and closer and closer to the y-axis. That's x equals 0. And then also the horizontal line, y equals 1/8. So right here, just above the x-axis at 1/8, put a dotted line for the asymptote, and the function's going to get closer and closer and closer to that. And so it basically looks like a hyperbola. There's one branch of it. Here's another branch of it. And that's what the function looks like.